Hi, Dr. Charles Martin here with Calculation Consulting. Today I'd like to talk to you about the difference between doing data science and building machine learning products in your company. A lot of companies today have collected an enormous amount of data. They've been putting data into Hadoop. They've been trying to get things working in Spark. They have data running in Amazon Redshift or Google BigQuery. They've spent a lot of money doing this, a lot of resources, and now they would like to begin getting some ROI on that data. And a question arises. What is the difference between building a machine learning product and hiring and doing data science? When you build a machine learning product, the goal is to put something into production that can make predictions. And it's the job of the machine learning engineer, machine learning scientist, to develop models that can make those predictions. Let me give you an example. Let's suppose you're building a model to try to predict how much you should charge for an Airbnb apartment. Maybe you own a bunch of apartments, or maybe you have a website and you're trying to provide pricing for other people with apartments, and you would like to be able to predict the price of an apartment in a given neighborhood. It's the job of the machine learning scientist to figure out what are the features that go in that model that can predict the price. And they work typically with the product manager and the engineering team to get this product built and running in production. It looks something like you go to Hadoop, you pull your data out, you put it into Python, you run a model, you ask, do I have the features, do I not have the features, am I getting good predictions? You go back to the data science engineering team. You say to the data engineers, I need more features. I need different features. They build you the features. You try the model again. Maybe it works pretty well. You then say, okay, we're ready to put this model in production. You put the model in production and you build a predictor. And now when customers come to your website and they list their apartment, they're able to get an idea of how much they should price for their Airbnb apartment. The idea is typically you would refresh this data maybe once a week or once a month. You pull the data out again. The model is retrained. Maybe new features are added. You check to see how well it did, and you update it. What does this have to do with data science? What does the data scientist do? Well, you might ask yourself, well, what is it that's causing a particular apartment to have a very low price or a very high price? And you might know, for example, that this apartment's in a very crime-ridden neighborhood. And you may want to say that you want to price apartments in high crime areas lower than you price in a low crime area. You can charge more. And the job of the data scientist is to ask these questions and figure it out. Well, how is this different than the model? Well, let's think about what the example might be. Suppose the machine learning engineer discovers that a really good predictor for housing price is the number of trees in a neighborhood. It turns out that the more trees there are in a neighborhood, the higher you can charge for an apartment. This just seems to be how it is. And they can discover this by, say, going to Google Maps and downloading an image of the zip code, putting it into an Amazon API that can count the number of trees, or maybe just counting the number of green pixels in the image and using that to predict price. Now, this example is somewhat contrived, but it's very important to realize that the number of green pixels or the number of trees in a neighborhood does not cause the price to be high or low, and it certainly does not cause the crime rate to be high or low. The data scientist might ask, what causes the crime rate to be higher or low? And if they were to go and look at the machine learning model, it would say, well, it's the number of trees in the neighborhood that dominates. Now, the problem is that really causal? And by causal, what do I mean by causal? I mean, what could you do as an apartment owner? Do you think, well, I'll just plant more trees, and by planting more trees, I can charge more for my apartment that I'm renting? Well, maybe. But if you're really worried about crime rate, then you would ask yourself, what are the things I could do to affect the crime. Well, obviously, planting more trees in a neighborhood is not going to cause the crime rate to go up or down. You have to give people jobs. That's what causes crime rates to go up or down, because crime rates are typically thought of being related to income. But you cannot really input income into your model. So the difference is that in a machine learning system, you're building models that make predictions. Why these predictions work, it is not necessarily causal. And you might say to yourself, well, I have this black box model and it just makes predictions, and we're fine with that. You might then say to yourself, well, what I want is a white box model that I can look inside. But even if you look inside the model, you might not be able to make any changes. The features that the model generates may not make any they may have no commonsensical idea of this is what causes the model. So a data scientist is someone who asks questions. They're a scientist. They design experiments. And they ask questions. Why does something happen? What caused something to happen? What can we do to change the outcome? What are the things we can do to increase revenue, to keep more customers, and so on? So the difference between doing data science and building machine learning products is that the machine learning engineer is going to build a model that makes good predictions. The data scientist is going to ask questions. Why did something happen? How can we change it? And they're going to design experiments to test these scientific hypotheses that they have. I hope this was helpful, and I look forward to seeing your comments, which I'll try to respond to on the channel. Thanks for watching.